First difficulty in LPP or simplex is infeasible or inconsistency in LPP. And if we have one constraint equal to twice x1 plus x2 less than equals to 20, does it mean that x2 equal to 0, then twice x1 equal to 20, so x1 equals to 10. So this one is 10 value. And second time x2 equals to 20. So second time x2 equals to, so this line which is passing through 10, 20 and below this region, is it a feasible region? So this one is feasible region. We have a second constraint which is equals to twice x1 plus x2 greater than equals to 40. We have only two constraints. One constraint is given by equation 1 and second constraint is given by this equation. So this time if I put x2 equal to 0, twice x1 equal to 40 and x1 equal to 20. So will I get this value? And next time if I put x1 equal to 0, I will get x2 equals to 40. So let's say x2 equal to 40 here. Now this line here which is passing through 20 and 40 is this line will have a region like this. Why it is a region like this? Because this one is greater than. So do you have any common solution or you don't have any common solution? If we don't have any common solution. If we don't have any common solution, we cannot find out the value of either z max or z minimum. This type of system is called as infeasible or inconsistency in linear programming. So what we conclude is that if both the constraint cannot be satisfied simultaneously, then the given system is called as infeasible system. The second type of difficulty come across is called as redundancy. I will twice x1 less than plus x2 less than 20. Does it mean that I have one point equal to 10 and other point equals to 20? And because of this one, I have one line like this which represented by this one, and is a region below this is always true. That is this region. Just like this one, but the value will be like this, twice x1 plus x2 less than equals to 40. Now this time, this line will pass through x1 equals to 20 and x2 equals to 40. Now if I draw this, is the solution is deferred or solution will not deferred? Is the common solution is still given by the constraint number 1. So whether we have this constraint or we don't have this constraint, will the effect on solution matters or does not matter? That is the second equation is called as redundant equation, because you are not getting any information from the second information. So the second condition is called as redundant solution. So in word we can put like this: a set of constraints is said to be redundant if one or more of them are automatically satisfied. That is, this constraint is automatically satisfied by first constraint. In that case the solution is called as redundant solution. So to understand this concept of degeneracy, let's have one constraint equals to twice x1 less than equals to 40. It means that x1 less than equals to 20 is it universally true. So anything that is this line represents x1 equals to 20. So is the left hand side region, that is this region, is it true? It's the open region. As you go upward, it will open. So this is. So we have a second constraint, x1 minus x2 less than equals to 10. So if x1 minus x2 less than equal to 10, if you put x2 equal to 0, is x1 equal to 10. So x1 equals to 10 is somewhere here. And if you put x1 equal to 0, will you get x2 equal to minus 10? So minus 10 will be on this side. So somewhere is minus 10. So if I draw the line like this, is this line represents x1 minus x2. So this line represents x1 minus x2, and if I want to say less than equals to 10, then is this region is universally true. This side is the lower side and this is the higher side. This side is greater than, this side is less than. Now do you have a bounded region here, or this region will go on increasing? this region will go on increasing. If you take this point and you find the value of Z max, and if you take then this point, because this is also a valid point, then is it value will go on increasing. So after every step your value will go on increasing and increasing. So will you come to any final solution, or your solution just degenerate? Just degenerate. It is continuous solution and never will stop, because it will end at infinity. So is it a bounded solution or is it an open solution? Open solution. That is called as unbounded region. This region is called as unbounded. Is this region is a bounded region? This region is bounded region. This region is also a bounded region, and this one is unbounded. This one is bounded, and this time even we have two constraints, we are getting this region, and this region is unbounded region. That is this one. If you start from here and you go to this side, is the upper limit is by infinity. Is open or closed? Open. So the values of the variables may increase indefinitely without violating any of the constraint. That is, the solution space is unbounded. In that case, it is called as degeneracy. So to start with simplex tabulation method, we will first solve this problem by graphical. We have Z max equal to 6x1 and we have this type of constraint. So let's prepare here our graphical solution. So on this axis we will plot x1. On this axis we will plot x2. In this equation you can make equality, and first you put x1 equal to 0 and you can solve for x2. That will be 5. Then you put x2 equals to 0 and then you solve for x1. That equals to 5. It means that it will pass through 5, 5. So let's make this one approximately equals to 5, and this one is also approximately equals to 5. So any line that is passing through these 2 points will represent our constraint. So any region below this one is our required region. The last constraint says that your region is this one, is greater than, this one is x2 greater than, and this region is x1 greater than. It means that you have to work only in the first quadrant. And the second constraint says that if I put x1 equal to 0, then twice x2 equal to 12. So x2 equals to 12 by 2 equals to 6. If I put x1 equal to 0. And if I put x2 equal to 0, that is this value equal to 0, thrice x1 equal to 12. So x1 equals to 4. So any line that is passing from 4, x1 equal to 4 and x2 equal to 6 will represent the second constraint. So this one is second constraint. It means that the region which is enclosed by both, that is this region, is it our required solution. So we have one corner point equals to A, we have one corner point equal to B, we have one corner point which is obtained by intersection and solving these two equations simultaneously, and one corner point is D. x1 plus x2 equals to 5, twice x1 plus twice x2 equals to 12. If you solve this equation, x1 equals to and x2 equals to 3. So coordinate of this point is 2, 3. So we are able to calculate the value of Z max for point A. So for point A we have 0, 0. So our value of Z is also equals to 0. For point B, our x1 will be equals to 0 and x2 equals to 5. So we can obtain the value of Z max equals to, this one is 0 and this one is 5 into 5, 25. You can see our coordinates are 2, 3. 2, 3 will generate the value of Z. 6 times 2, 12, and 3 plus 15, 12 plus 15, 27. And finally we are at D, which is the solution of 4, 0. So 4, 0 will be 24, 7. And this solution is obtained at x1 equal to 2 and x2 equals to 3. Now you are going to solve this problem by some standard technique that is called as simplex table method. So for this one, if we have a constraint less than, it means that you are allowed x1 plus x2 less than equals to 5. Maximum quantity equal to 5. And sometimes it is greater than, it means that you are allowed minimum quantity equal to this, and anything maximum you can. So if the constraint is less than equal to, you have to introduce slack variable Si, S1, S2, S3. And if you have greater than equals to, then you have to introduce surplus variable because it is greater than. That is why it is called as surplus variable, and less than is called as slack variable. And if you are equal to, then you have to introduce artificial variable. You have to introduce the slack or surplus or artificial. So my first constraint is x1 plus x2 less than equals to 5. So I will introduce my slack variable as x1 plus x2 plus s1. As soon as I put s1, so what is the difference is there will be adjusted in s1, and I have equal to sign equals to 5. And then I have second constraint is also less than, so I will introduce one more slack variable, that is thrice x1 plus twice x2. Another slack variable is s2 will be equals to 12. So if I not exhausted thrice x1 plus twice x2 capacity, so some variable is left with me. That number is always positive. So s1 and s2 are called as slack variable. So your first job is to convert the inequality into equality by using either slack, surplus or artificial variable. So your Zmax has to be modified as per the objective function, and since we are using a slack variable and initially we assume we have zero contribution of slack value s1 and zero contribution of slack value s2, and then we will modify this solution. So we will arrange this information something in a standard form. What are the basic variable? Now here you have to write constraint 1, constraint 2, constraint 3 like this. What is the coefficient of x1 for constraint 1? 1. What is the coefficient of x2 for constraint 1? 1. Coefficient of s1? 1. And this one is right hand side, and this right hand side equals to 5. Is the s2 is not present in the first, so can we write coefficient equal to 0? Similarly, I will write down the second constraint. The coefficient of x1 is 3, coefficient of x2 is 2, coefficient of s2 is 1. It means that the coefficient of s1 is 0, and the right hand side equals to 12. Additional value we have in equation 1, s1. So you have to write here s1, and you have to write here s2. That is s1 from first and s2 from second. And when you write this, you have to check what is the coefficient of this one in the first row. So what is the coefficient of s1 is 0, and what is the coefficient of s2 is 0. Now why this 0 0? Now check your solution. Does it start from 0 0? Is it correct? That is why we start our solution from 0 0 by assigning 0 0 to s1 and s2. Now observe this. This one is s1 and this one is s2. Now observe the s1 s2 here. S1 s2. Whatever the variable you write here, it must have, if you write s1 and s1, it must be equals to 1. If you write s2 and you write s2, this must be equal to 1. Now you are familiar with this matrix. Is it an identity matrix? This one is identity matrix. So every time whatever you write here, that you can check on this side, and it must be a identity matrix. So once you do this matrix, then you have to do first calculation, that is called as Cj minus Zj. So Cj minus Zj, you have to write this value at this point. So this value says that, what is this number? This 6. So you have to write this number 6. 0 multiplied by 1, you have to subtract it. 0 multiplied by 1. 0 is also subtracted. 0 multiplied by 3. So is this number is 6 in this column. Now I will go for second column. For second column is, what is this number? 5. 0 multiplied by 1, 0 multiplied by 2, is it the same number? It means that, can I copy down my first number as seen from this one? And I will do not execute this step, my first step. So I will just copy down this number 5. Now 0 minus 0, 0 minus 0, is it also 0? And this 0, and this is also 0, and this one is also 0. So is it 0? Is this fine? So that is the first step, that is called as Cj minus Zj. To select the key column from this one. If your case is maximization, then you select the most positive number. So most positive number or highest positive number. Minimization, select the least or the most negative number. Now what is most negative? The lowest value of negative number. That is minus 5 and minus 10. So you have to select minus 10. And most positive, we have 5 and 10. So you have to select 10. Meaning is same. Maximization is positive and minimization is negative. And if all values, in case of maximization of Cj minus Zj are either equal to 0 or either equal to negative, then you conclude the optimal solution is achieved. Solution. Exactly opposite on this side. If all values of Cj minus Zj are either 0 or either positive, opposite of negative is positive, then we conclude the optimal solution is reached. Now since we are doing the maximization problem, we have to check the row of Cj minus Zj. If any of the row is positive number, then you have to select the most positive number, that is this one. So you have to place this arrow. It indicates the key column, key row. How to select? To select the key row, first you have to construct one more column here. That is called as theta column. And this theta column is basically the right hand side, that is the solution. Is it a S2 here or we have the solutions here? This is RHS side, no? So this one is RHS side. So this one is RHS divided by corresponding key column number. So what is this value? Is it 5? And what is the corresponding number? Is 1. So is this ratio is 5. Now what is this number? Is 12. Then what is the number in the key column? Is 3. So is this number is 4. So in this fashion you have to calculate first theta. Chalo aap try kar. Once we calculate this value of theta, select minimum value of theta. Select minimum value of theta. That is called as minimum value of theta. That is called as key row. So is this is the key row. Is it row 1 is a key row or row 2 is a key row? Row 2 is a key row. So we have a key column, and we have a key row. So can we find out the key element then? We have a key row and we have a key column. So this element is called as key element, or other number of times it is also called as pivot element. What does indicate that this row, that is S2 will go and S1 will enter. This says that this number will leave and this number will enter. So next time S2 is replaced by X1, 0 is replaced by coefficient of 6, and this number will be, you have to make it equals to 1. How it becomes 1? Because of identity matrix. So first of all, this one is called as key column. Why it is called as key column? Because this is the most positive number. Then in the column of theta, which one is minimum number? Is 4. That is called as key row. Corresponding to key row and key column, we have key element. called as pivot element. And according to key row, S2 will leave and X1 will come. Which one is leaving variable? That is decided by row. And which is the entering variable is decided by column. So which is entering element? X1. And which one is leaving element is S2. Next time in our table, S2 is replaced by X1. Now, which one is the leaving variable? S2. And which one is the entering variable is X1. So this one is X1. What is the coefficient of X1? 6. Now this time is S1 and X1 must make unity matrix, that is additive matrix. I want to make entry in all these elements. So this is same as the previous one, so no modification on this side. And S1 is same because there is no key row or key column inside this one. Only pivot element is this one, so S2 is replaced by X1 and the coefficient of X1 is 6. Since S1 is here, you make equals to 1. That is compulsory. And this one is X1 and this one is X1, so it must be a additive matrix. So you place 0 and you place 0. Rest 6 numbers you have to calculate. But before this, the previous number was 3 and now the number is what? 1. It means that I have to R2 dash, I can operate from the previous row, that is R2 divided by the same number equal to 3. So I will continue this. 3 divided by 3. 3 divided by 3, is it 1? 2 divided by 3, so I will just write 2 divided by 3. 0 divided by 3 is 0, so we don't have to calculate actually. And this one is 1 divided by 3, so this one is 1 by 3. And this one is 12 divided by 3, so this number is 4. Orally you can do this and very fast. Now, is this number is compulsorily 0? Okay, how you get this 0? What was the previous number? 1. So you have to write down R1 dash. How you compute this number is R1. Okay, that is R1 is this number 1. But what is this number is 0. So minus of. What is the coefficient of this one is 1. So is it simply equals to R2 dash. Now check me. What is the previous number? 1. What is the new value of R2 dash? 1. Is 1 minus 1 is. Let's confirm this for this one. Okay. Now what is the previous number? 1. What is new number? 0. So is it number is 1. So not only the additive matrix will make you problem easy, it also instruct you how to write the second equation. Now how are you going to fill this? So what is the original number? 1. Original number is 1. What is new number? 2 by 3. So is this number is 1 by 3. So this number is 1 by 3. What is the previous number? 0. What is the new number? Minus 1 by 3. So is this number is minus 1 by 3. What is the previous number? 5. What is the new number? 4. So what is this number? 1. Let's calculate Cj minus Zj one by one for this row. This one is 6. 0. This one is minus. 0 into 0? 0. 6 into 1? 6. 6 minus 6 is 0. Next. Now what is the number? 5. So I will write 5 minus 0 and 6 into 2 by 3. Is it 4? 12 divided by 3, number is 4. So is this number is 1. Agree? Next. This one is 0. So this one is 0. 0 into 1, 0. And 6 into 0. So is this number is still 0. This one is 0. So this one is 0. Okay. This one is 0. 0 into minus 1 by 3 is also 0. And 6 into 1 by 3 is this number is plus 2. So is this number is minus 2. Okay. If you write this also, then you get a profit at that point. If you are interested. 0 into 1, 0. 6 into 4 is 24. Check your graphical solution. At 40 is your profit is 24. Full proof method. Now you perform this step and then we'll discuss. Once we calculate Cj minus Zj, you have to check that is there any element is positive. If any one element in this row is positive, it means that the solution is not optimal. If the solution is not optimal, then you have to select the most positive value. So this value is the most positive value. So this one is called as key column. The key column, we have to calculate theta, which is basically equals to right hand side divided by key column number. For example, this one is 1. So 1 divided by 3. So is this number is 3. Next, this one is 4. 4 divided by 2 by 3. 2 by 3. 2 by 3 is 12. 12 by 2, is it 6? Which number you have to select? Smallest value of theta. So we have to select smallest value of theta. So this one is key row. Then is the number or key element. If this one is key, then S1 will leave. Then which number will come? X2 will come. So which is the leaving variable? S1, and which is the entering variable? X2. We have a leaving variable equal to S1 and entering variable equal to X2. First entry, you have to make this one. Entering variable is what? X2. Now what is the coefficient of X2? 5. Once you write this X1 and X2, you first finish up your information about identity matrix. X1 and X1, you make it 1. X2 and X2, make it 1 and write 0. It means that you have to left with only this calculation. The previous this number is equals to what? 1. It means that is this row, entire row, is it multiplied by 3? So 0 multiplied by 3 is 0. 3 multiplied by 1 by 3. 1 multiplied by 3 is 3. 3 multiplied by minus 1 by 3 is minus 1. 1 multiplied by 3 is 3. Are you comfortable? So this is how I get the number 1, and I am guided that this number was previously 1 by 3. New number is 1. It means that I have to multiply this number by 3. That is my first calculation. This number. Is this number is previously 2 by 3? Now what is this number? Is 0. Now this one is I will call as R1 now. I will call this as R2. I will call this as R1 dash. I will call as R2 dash. I am interested in this number. That is my R2 dash. I want to find out how I am getting this value. So previously this number is 2 by 3. Now new number is 1. So what number should I multiply to 1 so that my answer is 0? 2 by 3. That is why my rule is 2 by 3 is coming from R2. Minus 1 is coming from R1 dash. That is I just modified. And is my 2 by 3 is a constant term. We continue with this formula. What is R2? This number is 1. This number is 1. And what is the new number? Is it 0? 1. That is R2. What is new number of R1 dash? Is 0. Multiplied by 2 by 3. Is your answer is 1. That we already done. Is it just a cross check? Okay. What is this number is? What was previous this number? 0. That is R2. This number is 0. Minus. What is new number? 3. Multiplied by 2 by 3. Is this number is minus 2. So this number is minus 2. Now what about this one? This is 1 by 3. So this is 1 by 3 minus, what is new number? Minus 1. Is it multiplied by 2 by 3? 1 by 3 plus 2 by 3. Is it 1? So is this number is 1? What is the previous number here? Is 4. 4 minus, what is new number? 3 multiplied by 2 by 3. Is it 4 minus 2? Is it 2? Is 3 and 2 is your answer. And x2, 5 into 3, 15, 6 plus 2, 12. Is the 27 your maximum profit? Check your graph. Is the 27 is your maximum profit? X1 is 2 and X2 is 3. Okay, and we just confirm that this one is our optimal solution or not. Okay, let me try for Cj minus j. 6. This one is 6 minus 5 into 0, that is 0. 6 into 1, is it plus 6? So is this number is 0? Correct? This number is 0. Okay, this one is 5. 5 minus 5 into 1, 5. 6 into 0, that is 5. 5 minus 5, 0. This number is 0. Minus 5 into 3, 15. 6 into minus 12. 6 into minus 2, minus 12. This number is 3. And is this number is minus 3. Correct? Then last number. This one is 0. Minus 6, 5 into minus 1. Minus 5. 6 into 1 plus 6. This is plus 1, minus 1. Is all these number are either 0 or either negative, is the optimal solution is reached. And therefore x2, x1 value must equal to 2. And your x2 value must equals to 3. That is the solution. And what is the profit?